circling it back around to adaptive defenses. Now, we've already talked a little about these, how they're specific and they target certain things, but let's dive a little bit deeper into that. Now, the adaptive immune system, looking at anything that's abnormal body cells as well as infectious agents. So your pathogens, you're looking at bacteria, viruses, anything that can infect your body, but as well as the abnormal. So you're thinking things like cancerous cells, for example. It's helping to amplify the immune response, amplify the inflammatory response specifically. So as you increase the inflammatory response, this works in conjunction with what we just talked about in the previous videos. So you can really amplify that immune response for inflammation quite a bit. That's why sometimes certain things can really start to inflame and swell up. And you're activating the complement protein series. Now again, we don't have to know every one of these, which one is C1, C2, C4, C5, C3. The idea is know the complement protein is meant to destroy and cause cell lysis by basically boring that hole in and activating more macrophages. So we know that it's specific. That's nothing new. It's also systemic. That means it's head to foot. It's the whole entire system, whole entire body. It's not just going to only work in one certain spot. And it has memory. That is an important point. Because by having memory, that means if you ever see the same thing again, you can recognize it and get rid of it faster. So what we're looking at here is a primary immune response. And if there's a primary, there's also a secondary. But let's start with the primary. The primary immune response is your first exposure to a specific antigen. That's why if you ever heard there's different types of bacteria, different types of viruses, different types of infections. That's why in certain cases, once you have one infection, you can't get that same thing again typically. Think of chickenpox, for example. Usually once someone has chickenpox, or they've had the actual immunization against chickenpox, they won't get it a second time. It can happen occasionally, but your body recognizes it, knows what to do, and can stop it. Same thing has happened a lot of times in this winter time for flu, but there's influenza A, there's influenza B, there's different strains. Typically, you don't get the same strain twice. You can get the different strains and be unlucky, but you don't typically get the same exact one over and over because your body has memory. This gives about a 3 to 6 day lag period. Now, what's happening here is your body's infected. You need to recognize what's going on and start to build up the responses. It can take 3 to 6 days to form a full response against this for your body. That's sometimes why these viruses can last 7 to 10 days on first exposure, because it takes time to build up your response. And then peak levels of antibodies are right around that 10-day mark. So by the time you hit that 10-day mark, you maxed out the antibodies in your system, you have maximum response, and usually by that point, you're starting to feel better, if not doing a whole lot better, because your body has been fighting at this point. That's the primary immune response. The secondary immune response is a whole different ballgame. This is now re-exposure, only with re-exposure. You're looking within hours, those memory cells are reacting. So not 3 to 6 days, within hours of infection, your memory cells are reacting saying, hey, I know what that is, here's how you get rid of it. And then 2 to 3 days later, you've peaked with your antibodies. 2 days compared to that first response of 10 days, it's a whole lot faster response. You typically don't get as sick or even get sick in the first place. So this secondary immune response is a lot more efficient because your body knows what it is. It knows how to fight it because you had those memory cells. So here's kind of a look at what we're seeing here. First response is this whole thing over here. In the first response, you're seeing that the antigen is being recognized. So you start forming these clones, the B cells. B cells, remember, make plasma cells, make antibodies. But you're also making, importantly, this memory cell. That memory cell is how your body's going to know how to fight it in the future. But beyond the memory cell, you're making all these plasma cells that are making the antibodies. You're now able to fight off the infection. But this secondary response starts with that memory cell. Now, it's not going to be the same one from the first time. These are usually clones of that ancestral cell. And the cells only last so long. But those cells recognize it, and within hours can mount a very efficient response. And you peak, as we mentioned, about 2 to 3 days later. So you're kind of looking at this graph here. Initial exposure, you then can see the concentration of antibodies goes up, and then it starts to kind of fall back off. Second exposure, if you notice, we're not quite at 0, because you still have some of those antibodies floating around because you know what this is. But look how much higher this secondary immune response is. You have a huge increase in the amount of antibodies that are produced to fight off this infection. And that's why it's so important to keep those B memory cells, because they see this new infection and they can have a much faster and much larger response to get rid of that infection. So primary and secondary immune responses. The primary takes a little bit longer, but sets you up for the future so you can have that secondary be much faster and more efficient immune response.